Alright, for today's lesson we have 1.1 notes over correlation, association, and causation. Today's learning target is I can determine the type of correlation that exists in a set of data and whether or not there is causation. Okay. First vocabulary word is going to be association. Association is a set of data with two variables, typically x and y is what we're used to. This is going to be two things happening simultaneously, guaranteeing that there's an association, but not necessarily a correlation. Okay. Next, we have correlation, the tendency for two values or variables to change together, either in the same way. When they're in the same way, we're going to call that positive, or in the opposite way or the inverse way, which would of course be the negative. Okay. Visually, correlation. You'll see this one. As our x value is increasing, our y value is also increasing. So both increasing, so that would be positive. The following one, as our x value increases, our graph is trending downward. So as one increases, the other one is decreasing. So that would be a negative correlation. And the next one is just random. There is no rhyme or reason to it, so we're going to say no correlation. Okay. Lastly, causation. Essentially, one thing causes the other to happen. So when the change in one quantity causes the change in another. There's a few things we look at when we determine whether it is causation. Must be scientifically provable that one causes the other. If there is a causation, we can determine the independent and dependent values. And then, of course, the dependent value will always depend on the independent value. Having a positive or negative correlation does not, I repeat, does not guarantee causation exists, just that there is an association. Okay. In each situation, tell whether a correlation is likely. If it is, tell whether the correlation reflects a causal relationship or just an association. Explain your reasoning. Okay? The amount of time you spend working out and the amount of calories you burn. Okay? The more I work out, the more calories I burn. So both are trending upward. Or if I don't work out, they're both trending downward. The less I work out, the less calories I burn. So I would say there is a positive correlation. Scientifically, can you prove that working out causes you to burn calories? I would say yes. So in fact, we do have causation. Next, the price of bread and the price of milk. Not really related, so I'm going to say there's probably some kind of association there. However, I can't determine just from that information what kind of correlation we have. And then lastly on this front page, the amount of money in your bank account. So the more money in my bank account and the number of items you purchase. So the more money in my bank account, the less items I purchase. Or you could also think of that backwards. The more I purchase, the more I purchase, the lower my bank account goes. You see those arrows are going in opposite directions, so that would be a negative correlation. And money is one of those things that's very easily to prove that one affects the other, so that would be causation. Okay, page 2. So right here we have a graph comparing students to the hours students have studied compared to their test scores. So before we get into it, if you just think about it, if the more you study, obviously the higher your test scores should go if you studied correctly. All right. First, is there association? Why or why not? Well, yes, we do have association because we're comparing two types of data at the same time. Next, what type of correlation does the data have and why? All right. If we look at it, you could argue that it's kind of spread out, but ultimately, as our X values increase, which would mean hours of studying, our Y values are increasing and getting higher there. So we have a positive correlation in general. More hours of studying will result in higher scores. And then lastly, the hardest one to prove is, does causation exist? Why and why not? I believe that yes, causation exists, because the more you study, the higher your grade or your score will go. So, yes, I would argue that it's provable that more studying would result in higher scores. Next, this is a new topic. We're going to cover it in detail later in the unit. But is the data a set of values that is distinct and separate? This is defined as discrete. Or is the data all-consuming, continuous? Why or why not? Be prepared to discuss and defend your opinion. I'm going to tell you that this is discrete. The reason I know it's discrete is because it is a scatter plot. You see where it says separate? There's gaps in the information. If it was continuous, it would be one solid line, and we're about to produce that solid line by drawing a line of best fit. But for right now, this data is discrete, meaning all data points are separate and unconnected. All right. Next, draw in a line of best fit on the graph. Find the equation of the line. Let's see, make sure I leave myself room here. Zoom out a little bit. Okay. Step number 1. If you want to produce a line, you're always going to have 2 points. So step 1. Pick 2 perfect points. Okay. When I say perfect point, it's in a connect or line up right at the whole numbers. All right, so the first one I'm going to do would be this one right here. I'll circle it to make it easier to see. That point would be 173. And my other point will be this one right here, which is at the point 381. Okay. In a moment I'll show you why I chose those points. So I'm going to use my straight edge. So typically when you choose a line of best fit, by hand, because if we do it in the calculator is going to do all that work for us. But by hand, we're going to have the same number of points above the line as below. So, you see above we have 1, 2, 3, and below we have 1, 2, 3. All right, next. Once we have our 2 points, we need to identify our slope. Remember, slope is always rise over run. Okay. So, how many do I go over? How many do I go up? To start off, we have a positive slope because it is trending upward, just like our correlation is positive. They match, slope and correlation. So, if I find my slope, aka my m in y equals mx plus b, I'm going to go over 2. So run goes on the bottom. I'll go up 1, 2, 3, 4, 5, 6, 7. Nope. Nope. From 73 I go up 8. Okay. And we know 8 divided by 4 reduces, or sorry, 8 divided by 2 reduces to 4. Alright, next. If we can continue our graph down, we notice that we have a y-intercept at 71. So those are the 2 things we need to produce an equation. So now our equation, so lastly, we'll put it all together and produce an equation. And our equation will read y equals 4x plus 71. Next, is the line of best fit a set of values that are distinct and separate? Or is it a continuous line, or is it continuous? Now this is where I was getting at before. So before, it was just a bunch of dots, so we called it distinct, or discrete, excuse me. Now, since we produced a line, there is no gaps in this line. So now it's going to be considered continuous. Meaning no gaps in graph. And then lastly, use your line to predict Sally's score if she studied for 6 hours. Now there's 2 ways to predict the score here. One of them would be mathematically. Since we have an equation, we could always use the equation and say y equals 4. I'm going to replace x with 6 hours because x represents hours studied, and then plus 71. So if I do the math, 4 times 6 would give us 24, plus 71 gives us 95%. So it's that simple, right? 6 hours of studying, and you will get your middle A. You could also do it by the graph. So if I study 6 hours, which is right here, and I follow that up to my line, and then I follow it back over to my y, if we judge it by looking at the graph, it will tell us the graph says we would make a 91%. All right, thank you.